Hi class, it's Professor Rourke. I wanted to make a video from one of the questions from chapter 7. These questions can be sort of tricky, and chapter 7 introduces us to continuous variables. So unlike chapter 6, where when we had a graph and we were asked to calculate the probabilities, we could maybe use the add up the heights of the bars. Or we could use something like StatCrunch, and they would also calculate this by adding up the heights of the bars. These variables are now continuous, so it's a little different. We're still going to try to, now instead of like adding up the heights of the bars, we have to find the area underneath the curve, or in this problem, it's not a curve, it's like a rectangle. So this problem is uniform distribution, which means that whatever the continuous variable is, there's an equally likely chance that at any time in there, it has the same probability. So this was from 7.1. This was question number 5. The question says, the graph to the right is the uniform density function for a friend who is X minutes late. Find the probability that the friend is at least 10 minutes late. Okay, and then the graph to the right that they're referencing, I'm going to click a button to pop it out, has an X and Y axis. The X axis on the bottom says time in minutes, and it starts at 0, and then it keeps going. The last mark labeled, though, is 30, and it looks like it's counting by 5s. Then the y-axis says density, because these are all now referred to as probability density functions. That's the word that we're going to use, especially for any continuous variable. They're going to label it density. And then what's interesting here is that they labeled the height as 1/30. Okay, so let's talk about this first, because that alone can be confusing, and there are some questions about that. So whenever the probability is uniform, okay, so uniform means, again, specifically, it's continuous, right? Because time is continuous. It's not discrete. They're not talking about like 1 minute, 2 minutes. Technically, what they're talking about is like 10 minutes and 1 second, 10 minutes and 2 seconds. It could be 10 minutes and 3 seconds and 3.54 seconds, right? It's measurable. It's not countable. We can't count the time. So in order to solve this particular problem, the reason the height of the graph is 1/30 is because for all of these probability density functions, whether it's a rectangle or it's more of like a curve, like we're used to seeing, like a normal curve, the area under the curve is always 1, right? 100% of the data is underneath the curve. Right, we kind of understand that, right? And so that means that the area under the curve is 1. So whatever the x-axis goes to, so for here, it goes to 30 minutes. I'm sorry, my kids keep coming in. They're driving me crazy. Okay, so the height of the bar is going to be 1/30 because it was a span of 30 minutes, right? So we know the area is 1, and we know the area of a rectangle is length times width, right? So each time the area of these rectangles is 1, and then whatever this, you can call it width, you can call it length, it doesn't really matter. Let's say the length of this rectangle. Okay, sometimes they call it the possible range of values, whatever it is. So if it's anywhere in 30 minutes, it would be 30. If it was anywhere within 60 minutes, it would be 60, whatever it is. However many range of values there possibly are, that's what's going to be the length of that rectangle. So hopefully it makes sense that if we're talking about like the height of the rectangle, which here I refer to as W, it would be 1/30, right? So if it was, again, out of 60 minutes, it'd be 1/60. If I could be late anywhere in 45 minutes, it could be 1/45. So hopefully that makes sense. And again, the graph does show that the height of the rectangle is at 1/30. That is the only mark labeled on the y-axis. So all of that is to set this problem up and to do some explaining. And now it says, find the probability that the friend is at least 10 minutes late. So at least means 10 or more minutes late, right? So I'm sort of a visual person. So what I'm doing is I'm going to draw a line, a vertical line from the top of the rectangle on my graph down to 10. Okay. And I'm talking about, at least we're talking about everything to the right of 10. Really, this person, I'm also often late, so sometimes refer to it as me, is somewhere between 10 and 30 minutes late. right? Because that's what this is saying, is that this person always arrives, your friend's always within 30 minutes, but we don't know when they're going to show up. And we're trying to find the probability that the friend is at least 10 minutes late. Okay, so in order to find the probability for these, again, we have to find the area of whatever they're referring to. So the area of this particular uniform, again, is just length times width. The length of the rectangle now isn't 30, like it wasn't 0 to 30. We're just focusing on 10 to 30. Okay, so the length of the rectangle from 10 to 30 would be 20, right? And then the height of the rectangle, again, they told us before, was 1 over 30. So we can just use our calculator to multiply 20 times 1 over 30, which is 2 over 3, which I think they want as a decimal. So that'd be like 0.67. Okay, so I hope this helps. This is the same process that you're going to use to solve these uniform distribution problems, where we have to think of it as a rectangle. A lot of times they're going to give you the graph, but if they don't give you the graph, in theory, we could be able to sketch this out ourselves. If it said that your friend was always somewhere between 0 and 30 minutes late, but you never know when they're going to show up. And then we could use that to find the height of the rectangle as 1 over 30, and then any combination of possible times we could find, but it's by thinking of it as a smaller rectangle. Okay, so I hope this helps. Again, I know it's a question that a lot of you had, but please always let me know whatever questions I can help answer, because that's what I'm here for. Okay, thanks.